talk about the reactions of alcohols. So alcohols and all your other hydrocarbons will undergo combustion. Okay, there's a general equation. You don't have to know it. You just have to be able to write a balanced chemical equation for combustion. Remember, if it's complete, it forms carbon dioxide, incomplete carbon monoxide. Okay, now an example of combustion and alcohols is ethanol. If you filled up a car recently, you noticed probably something that says like this fuel contains up to 10% ethanol. Well, ethanol is a real common solvent. We'd already talked about that. It's also becoming more popular as a fuel because it is an exothermic reaction. Now, it is partially oxidized, so it's going to release less energy. However, it can be obtained by the fermentation of biomass, meaning like plant matter. And so in some countries, we mix it with gasoline. It produces gasohol, which decreases our dependence on crude oil. Now, there are major proponents of this. There are major critics of this, and I'll just let the political cartoons speak for themselves. Okay, the other reaction that alcohols undergo is oxidation. Okay, and so we're going to give you a practical example before we go through the details of this. We're going to start by talking about ethanol. So ethanol can be oxidized by reacting it with acidified potassium dichromate. And the orange dichromate is reduced to green chromium 3 ions as that ethanol is oxidized. And that's actually how a breathalyzer works. You blow through, a tube that has those acidified potassium dichromate crystals in them, and there's a detector to see how much color change happens to then estimate a blood alcohol content. And for kicks and grins, I'll let you pause the video and just enjoy reading that. Okay, so here's what actually happens. The ethanol is exposed to acidified dichromate, that's how we write that, to form ethanal, your aldehyde, and then can continue, if it's continue to be exposed to our oxidizing agent, to our dichromate, it forms ethanoic acid, which, by the way, is vinegar. So yes, if you let wine sit around for a long time, it does turn to vinegar. Don't try this at home. Okay. Now, the neat thing about this, though, is that we can stop this reaction at the ethanal stage based on the various boiling points. Ethanal doesn't hydrogen bond. Ethanol does, ethanoic acid does. So it has a much lower boiling point. So we're able to distill ethanol from that reaction mixture as it's formed and just to isolate the aldehyde. But if we want this reaction to go all the way to the carboxylic acid, to the ethanoic acid, then we're going to use what's called a reflux apparatus so that the ethanol continues to be oxidized. And so here's what those two things look like. Here's your distillation apparatus. So here's your ethanol. It's being heated in acidified dichromate. The ethanal, the aldehyde, forms and it evaporates, and then it comes down this condensing tube. Okay, there's water running, there's a tube within a tube, and there's water running on the space between the two. So this cools it, condenses it, and here is your distillate, your ethanal, your aldehyde. But if you want to form the ethanoic acid, you have what's called a reflux condenser. So you also have a tube within a tube, but it's stoppered up here. And so stuff will evaporate, be cooled, condensed, come back down, and continue to be oxidized. Okay, so all primary alcohols, meaning the alcohols at the end, will be oxidized to an aldehyde and then to a carboxylic acid. Okay, but we can actually use this oxidation reaction to distinguish between a alcohol that's primary, secondary, or tertiary, because this is what happens with a primary primary alcohol. If it's secondary, so here's our alcohol group, our carbon is bonded to 2 other carbons, we form a ketone, and then it can't undergo further oxidation without breaking our carbon chain. So if we isolate ketones out of this oxidation reaction, we had a secondary alcohol. And then a tertiary alcohol, so we have our alcohol, here's our carbon, it's bonded to 3 other carbons, won't be oxidized in these conditions. There's no place for extra hydrogens to attach to the carbon. We'd have to break the carbon chain. So tertiary alcohols can't be oxidized by acidified dichromate. They can be oxidized by, say, burning them. But again, by doing so, we destroy or break the carbon chain. Okay. Our third reaction for alcohols is a condensation reaction. So think about like what condensation means just in everyday layman's terms. You talk about the formation of water. Well, condensation reaction is a reaction between 2 molecules that results in the formation of water as a bond is formed between 2 functional groups. So here, for an ester, we have an alcohol and a carboxylic acid, and they form an ester and water. So you can see our OH and H here are going to form water. So this is ethanoic acid reacting with ethanol to form ethyl ethanoate. Now a quick reminder about ester nomenclature is that the leftovers, the alkyl group, the leftover from the alcohol is the YL part, the enoate is from the carboxylic acid part. So some stuff about esters. A lot of your distinctive fruity smells, apple, pear, banana, all are esters. And so we use these as natural or artificial flavoring agents because a lot of taste comes from smell. A lot of the perfume industry is based on esters. Now, some are also used as plasticizers, and you might have heard of phthalates, and that those have some health concerns. Go ahead and look it up if you want. Okay, try and do this though. Write a condensation reaction for the formation of the following ester and draw the final structure. So methyl ethanoate. I'm going to talk you through this one. So methyl came from the alcohol, so we're going to deal with methanol. And then ethanoate, that came from the carboxylic acid, so ethanoic acid. And then we're going to draw our structure. Okay. And then, of course, we'd say plus water. But here's methyl ethanoate. And so I want you to try this one on your own, pause the video, and then you can restart it when you're ready. All right, hopefully you got propyl, so propanol, 1, 2, 3 carbons with your alcohol right here. Methanoic is methanoic acid. So here we go, and there we go. All right, that's it for alcohols for the day.